Let's continue working with building quadratic function models. We're going to work on this problem. We're wanting to expand a garden by planting a border of flowers. The border is going to be the same width around the entire garden, and the flowers that we bought will fill an area of 660 square feet. We need to decide how wide the border is going to be. So here's our picture. I'm going to redraw it here in a second. What we have is an existing garden that is 5 feet by 3 feet. And around this garden we are going to plant a border of flowers. Now the flower border is going to be the same width all the way around. So I want to draw my border to be equal spaced all the way around here. And I know the area that I'm going to fill in with flowers is given. So all of this will be flowers. And they tell me in the problem that the area of the flowers is 660 square feet. Now in the picture, it's kind of hard to see. It labels each of these dimensions to be of length x. And since our garden is the same width all the way around, each of the lengths here are x. What we need to figure out is how wide the border should be, so in other words, solving for x. So x is going to equal the width of the border. So let's figure out what we know about our problem. Well, we know the area of the border, and we can figure out the area of the garden by taking the 3 feet times the 5 feet to get 15 square feet. So I know the total area of my plot. So my total area is 660 plus 15, or 675 square feet. Now I would find my total area by taking the entire length of the garden times the entire width of the garden. So if I look at the entire length from this end all the way to this end, this distance from end to end, notice that I have to go across x feet, and then I have to go 5 more feet, and then I have to go x more feet. So this entire length, this blue line that I just drew, is going to be 2x plus 5 feet from end to end. And by a similar process, my width is going to be the same thing. I have to go from x to x, and then I've got to go 3 more feet, and then I've got to go across x again. So this width of the garden from end to end will be 3 plus 2x all the way across. So my total area of 675 square feet is going to be equal to the length of the whole plot, 2x plus 5, times the width of the whole plot, 3 plus 2x. Now I'm not quite sure what this looks like yet, but I know that I can do some algebra by foiling these two binomials. So I have 675 equals, it's going to give me 6x plus 4x squared plus 15 plus 10x. So I have 675 equals, I'm going to make that 4x squared plus 16x plus 15. Now this is looking like a quadratic equation. So I have some choices about how to solve this. I could complete the square, use a quadratic formula, or I could try and factor it. I'm going to go ahead and subtract my 675 over here, so that I get 0 equals 4x squared plus 16x minus 660. Now it looks to me like I can divide each of those terms by 4, so let's try that. So 0 divided by 4 still gives me 0. I get x squared plus 4x minus, let's check that one on a calculator, 165. So I could complete the square on this quadratic formula, or I can try and factor it. Well, let's just complete the square. So I'll add my 165 back over, equals x squared plus 4x. So I have to find half of b, so 4 divided by 2 is 2 squared. When I square that I get 4, so I'm going to add 4 here, add 4 here, so that gives me 169 equals, when I factor this side, it's x plus 2 squared. Then I need to find the square root of 169, so I'm going to take the square root of both sides. So I get x plus 2 equals plus or minus 13. Subtract the 2. It gives me x equals negative 2 plus or minus 13. So that is 2 separate values. X could equal negative 2 plus 13, which is 11, or x could equal negative 2 minus 13, which is negative 15. Now remember, at the beginning of the problem, we assigned a quantity to x. X represents the width of the border. So once I get these two solutions, x is 11 and x is negative 15, I can automatically ignore the negative 15 because the border can't be a negative width. So the solution to my problem is going to be that the border should be 11 feet wide. Let's see if we can get through this next type of problem about businesses. So I'll just read that to you real quick. Many times businesses will raise their prices of goods and services in order to increase profit. However, when they raise their prices, they usually lose some customers. In such situations, the price at which the maximum profit occurs needs to be found. So here's an example. We have an auditorium that has 1,200 seats, and they have been filled to capacity for each show. Tickets are currently priced at $5 each, and the owner wants to increase these prices. He estimates that each time he raises the price 50 cents, he'll lose 100 attendants. So the owner needs to find the ticket price that will maximize profit. And then our questions are, what will the ticket price be that will maximize profit, and how much will that profit be? So let's set up an expression for our profit. The profit that the guy makes is going to equal the number of tickets he sells times the cost of each ticket. So with that basic amount of knowledge, we know we need to maximize profit. So that's the equation we're going to be working with, but we need to figure out some way to relate both tickets and cost to this 50-cent increase in price. Well, the price of the ticket is pretty easy to relate to each 50-cent increase in price. So what we're going to do is we're going to say that the cost of the ticket is going to be $5 plus 50 cents, but it's not just 50 cents, it's 50 cents times the number of times we increase. So if we increase it twice, then it'll be 50 cents times 2, which will be $1 plus our $5, so it'll be $6. Then, that's the cost of the tickets. That should go here. Okay, the number of tickets, I thought that was a dollar sign. The number of tickets is also related to how many times we increase our price. It says in the problem that currently they are all sold out. So they are currently selling 1,200 tickets. But it also tells us that each time we raise our prices, 100 fewer people come. So we have to subtract 100 times the number of increases we make. So now this is going to be our rough equation for profit. So you can see that both the number of tickets we sell and the cost of the ticket are dependent upon the number of times we increase prices. So that's what our variable is going to represent. X is going to equal the number of times the price increases by 50 cents. So let's now replace these words with variables. So P is going to equal 1200 minus 100x times 5 plus 0.5x. And then go ahead and FOIL this out. So P equals 1200 times 5 should be 6,000. Let's check it. Yep. 6,000 plus 1200 times 0.5x, 600x, and then 5 times negative 100x, so negative 500x, and then negative 100 times 0.5x, so negative 50x squared. So P equals negative 50x squared plus 100x plus 6,000. So we can take out a greatest common factor. Now let's divide out negative 50. That gives me x squared minus 2x minus 6,000 divided by 50 minus 120. Okay. Now I know that this graph is an upside down parabola, and again, each time I have an ordered pair, the coordinate is going to be x, which represents the number of ticket increases, the number of 50-cent increases, comma P, which represents profit. So right here at the vertex is where I'm looking for the maximum profit, the highest profit. So I need to find the vertex here. So I'm going to do x equals the opposite of b, so positive 2, over 2 times a. So x equals 1. Now that tells me that I should have this x equals 1, x equals the number of times we should increase our prices by 50 cents. So we should have one price increase. One price increase is going to get us to the vertex, which will be our maximum profit. So our new ticket price, so the ticket price that will give us the maximum profit is going to be one price increase of 50 cents. And originally our tickets were $5, so our new ticket price is going to be $5.50. Now we can figure out our maximum profit a couple of different ways. We can substitute 1 in for x in my profit equation, or we can go back to just kind of working it through common sense wise, that if our tickets cost $5.50 because we increased prices once, then we're going to lose 100 customers, so we'll have 1,100 tickets times the price of $5.50. So a couple of ways to do that. Let's see, I'm just going to substitute it in here. So negative 50 times 1 squared minus 2 times 1 minus 120. So that is 1 squared is 1, 1 minus 2 is negative 1, negative 1 minus 120 is negative 121, so negative 50 times negative 121 is going to give me a profit of $6,050.